Hi folks, welcome back. So this is a video companion to this blog post I wrote recently. I'll leave a link to it in the description. But I wrote this because I was reflecting on my recent experiences building agents for customers in various domains and contrasting that with my own experience in my domain, which is building software and coding, and how there's still a vast gulf between how good these coding agents are and agents in other domains. So that's what this article is about. So I don't think it is hype or exaggeration to say that looking back on 2025, the standout AI success story has been these coding agents and just how much they've completely upturned the day-to-day practice of software engineering. Maybe not for all software engineers everywhere, but at least for a significant fraction or those closer to the cutting edge. But it will come to the rest of the population eventually. But what I found was that that kind of very convincing success is an outlier, and I don't see it translating to other domains, at least not yet. And so this article is trying to understand why that is the case. And I think the core reason is that there are these properties of coding AI agents, things like deterministic outputs, or at least deterministically checkable outputs, clear success criteria, very, very rich tooling, whether it's the command line or APIs and so on. And all that gives you these immediate feedback loops. Did the test pass or fail? And if it didn't, what was the error? So all these properties are crucial to making AI coding agents effective. And these properties are not very commonly present in most other domains. That is the core reason why the somewhat astounding success of coding agents isn't translating to other domains. And by other domains, I mean any domain where the computer or using the computer isn't an end in itself. So, for example, if you're a lawyer or accountant where you use the computer as a tool, but the computer isn't itself the goal, or if you're a medical researcher or working in drug discovery research, so domains like that. I think one of the biggest reasons that coding agents are as successful as they are is because the people that build the models are themselves programmers and computer scientists. And so this leads to a very, very tight dog fooding and feedback loop. The people inside the major model labs are immediately the first line of users. They give feedback to the model itself. They build the harness. And so this tight feedback loop is essentially ensuring that the tools built for programming will get better very, very fast just because of the user population inside all the model building companies. The other big reason coding agents are so effective is that if you look at the training data, a big chunk of the training data is related to technical and programming topics. So all this domain knowledge of how software engineering is carried out, the granular day-to-day, hour-to-hour activities that a software engineer does, things like testing, CI/CD, debugging, architecture, code reviews, all this stuff, this is very well represented in the training data. So the models themselves are very conversant in this domain. And this doesn't really translate to other domains. If you're in all these other non-computer domains like, I don't know, material science or drug discovery, energy manufacturing, sure, there's some chunk of the training data that talks about these things, but not in such granular detail. I highly doubt that the day-to-day work of, say, a material scientist is reflected in the training corpus the same way that computer programmers' activities are. And so the models just don't know about the domain enough. Okay, here we have to take a slight tangent into highlighting the difference between agents and workflows. And this is a raging debate within the community itself, but I'll just say that at a very high level, a workflow is a predetermined sequence of steps, and it has a very specific end goal. And you can still use an LLM with workflows, and they will fill in small reasoning gaps or tool calls or how to go from one step to the other. So the LLM is filling some very scoped purposes in workflows, but it is still spelled out ahead of time. On the other hand, agents are much more open-ended. They will come up with their own sequence of steps using the model's reasoning and planning abilities, and then follow that plan that they themselves came up with. Now, of course, coding agents are very firmly on the agentic side of the spectrum. And I think what enables them to be very agentic and still be successful is how much domain knowledge they have of software engineering, like I was just mentioning. However, the vast majorities of quote unquote agents that enterprises and industries need and are asking for are actually workflows rather than fully open-ended agents that do their own reasoning and planning. In fact, it is very scary to a large company if you tell them that this agent is going to come up with its own plan and you don't have any inkling what it's going to be. They are much more comfortable with predetermined sequences of steps, aka workflows. All right, so coming back, one of the consequences of all these other non-coding, non-technical domains not being represented in the world knowledge of the models is that when you're designing an agent for one of these other domains, say material science or drug discovery research, the knowledge needed for an agent or a workflow to operate effectively in that domain is essentially tacit knowledge. This is knowledge in the heads of the domain experts. And it is extremely contextual, often very specific to the company within which they work, and almost always not written down anywhere. And so, if you want to build an effective agent for a domain like that, the problem essentially reduces to solving this tacit knowledge problem, somehow extracting this tacit knowledge in enough detail and specificity that you can give it to the model to operate effectively in that domain. And this is a very, very hard problem. It's not a technical problem, but it is a hard problem to actually extract this tacit knowledge and then to make sure that it actually is correct. It captures all the edge cases and the gotchas and so on. And if you look at a lot of startups out there, there's a lot of startups that do AI agents for X, or where X could be lawyers or accountants or something. The entire value prop of those startups is that they have taken that kind of domain specific tacit knowledge and encoded it into their agents. And that is a significant moat because this is a hard problem. So all those are the reasons that the kind of success you see with coding agents hasn't translated to all these other non-coding, non-programming kinds of domains, because the conditions that make coding agents effective are unique. They're not universal to other domains. But it also tells us what we need to do to make agents that work for all these other domains. You need to have all this domain knowledge. You need to have clear success criteria. You need to have good feedback. So if you see what makes coding agents so successful, all these properties we just talked about, and you try to bring those same properties to other domains, then you can hope to have agents in those domains that are as successful as coding agents have been in the programming domain. All right, check out the full article. And if you like content like this, consider subscribing, like the video, and I will see you next time. Thank you.